Right now, almost all the powerful magnets inside EV motors, wind turbines, and military hardware depend on one country's refineries.
Wait, you mean the same tiny metals in my phone can decide who actually builds cars, turbines, and even missiles?
Exactly. And in the last 2 years, that country started using export controls as a pressure tool on the rest of the world.
So if they squeeze magnet exports again, EV factories and even defense supply chains could stall?
They already did. Magnet exports plunged after new controls in 2025, forcing some automakers to slow production and triggering emergency talks with Washington and Brussels. Today, we'll see whether recycling old magnets and redesigning motors can finally break this rare earth trap, or just move the problem somewhere else.
Sure. So what's the plan?
First, China's current grip on magnet supply and the 2024 to 2026 policy shock. Second, the new urban mining plants shredding hard drives, EV motors, and turbines to recover rare earths. Third, the companies redesigning motors to use fewer or zero rare earth magnets, including in EVs and defense systems.
And at the end, I want a straight answer. Can recycling and redesign really replace new mining? Or is that just wishful thinking?
Deal. Let's start with the trap we're trying to escape.
Wait, but first, like and subscribe our videos to help us making more.
China refines about 90% of the world's rare earth permanent magnets, the ultra-strong magnets that make modern EV motors, wind turbines, and precision weapons possible.
So it's not just the mining, it's the refining and magnet making where they dominate.
Exactly. Other countries can mine ore, but turning it into high-performance neodymium iron boron magnets still happens mostly in Chinese plants. From 2025, Beijing rolled out 2 waves of export controls, first on heavy rare earths and magnets, then on more elements, and even the technologies used to make them.
And that hit EVs directly?
Yes. Magnet exports dropped sharply. EU magnet prices spiked up to 6-fold, and some Western car makers and defense suppliers reported delays.
So the obvious response is mine more elsewhere. Why isn't that enough?
Because bringing a new rare earth mine and magnet plant online can take close to a decade, and analysts still expect a major neodymium-praseodymium shortfall by 2030, even with new projects in the US and Australia.
So we need an answer that works in years, not decades.
Enter magnet recycling. Less than 3% of global rare earth demand is currently met from recycled material, but that's finally changing.
Where do you even find enough magnets to matter?
Everywhere. Old hard drives, wind turbine generators, EV motors, power tools, industrial separators, each packed with neodymium and dysprosium. In Iowa, one facility is urban mining millions of discarded hard drives a year, using an acid-free process to pull out rare earths with far lower environmental impact than traditional mining.
So those tiny hard drive magnets actually add up?
A single wind turbine can contain magnet material equivalent to around 200,000 hard drives, so the feedstock is huge if you can collect it. In the US, Re-Element Technologies is now turning scrap magnets from EV rotors, turbines, and hard drives into 99.5% pure rare earth oxides, with recovery rates above 90% and costs around $25 to $35 per kilogram, competitive with Chinese material.
That sounds like real competition. What about the actual magnet making?
In Europe, projects like SUSMAG-Pro use hydrogen-based processes to break old NdFeB magnets into a powder and re-sinter them into new magnets, recovering up to about 90% of their original magnetic performance.
So why isn't this everywhere already?
3 reasons. First, collecting magnets from millions of products is logistically messy and expensive. Second, The chemistry is sensitive. You need tight control over hydrogen pressure, temperature, and composition to keep magnet quality high. Third, today's recycling capacity is tiny compared to the demand growth in EVs, turbines, and defense.
So recycling can stretch supply and cut dependence, but it can't fully replace fresh mining yet.
Exactly. It's a powerful pressure valve, not a magic escape hatch.
What about just not using rare earth magnets in the first place?
That's the other big lever. Engineers are pushing three main strategies. First, rare earth-free motors. Induction motors, externally excited synchronous motors, and other designs that rely on copper windings instead of permanent magnets.
Like the old-school induction motors?
Yes, induction motors are inherently rare earth-free, and companies like Mahler and others have developed high-efficiency versions for EVs. Vallejo is rolling out a magnet-free, excited synchronous motor that cuts the motor's carbon footprint by around 30% at the component level compared with traditional permanent magnet motors.
What's the catch?
These designs can be a bit larger or less efficient at certain speeds, and they need more complex control electronics. But for long-range highway driving, or in tanks, ships, and large drones, where size is less critical, the trade-off can be worth it. Second, leaner magnets, using design tricks to get the same torque from fewer rare earths, like optimizing magnet geometry or adding cheaper ferrite magnets.
So even if you still use rare earths, you use less per motor.
Exactly. Many automakers have quietly cut the rare earth content of their motors over the last decade, and some next-gen designs aim to remove rare earths entirely from selected models. Third, frontier ideas. Contactless excited motors using wireless power transfer or new magnet chemistries that match neodymium performance without critical elements. Still experimental, but aimed squarely at breaking China's magnet advantage.
From a defense and supply chain point of view, which matters more right now, recycling or redesign?
Short term, recycling is the fastest lever. You can build urban mining plants near data centers, turbine graveyards, and EV scrapyards in a few years and instantly reduce how much fresh material you need from China. For militaries, having domestic plants that can turn scrap magnets into new, high-grade material means you're not waiting on export licenses during a crisis.
And redesign?
Redesign is the long game. Every new EV platform or missile system that moves to rare earth lean or rare earth free motors is one less hostage to future export controls. Analysts expect rare earth free options could reach close to 30% of EV motors by the mid-2030s, which would dramatically cut exposure even if China still dominates refining.
But we can't swap every motor overnight.
Right. EVs, turbines, and defense systems have 10 to 20-year lifetimes. That's why most serious strategies now combine three pieces: diversify mining and refining outside China, scale up magnet recycling everywhere, gradually redesign motors so they simply need fewer rare earths.
So, can magnet recycling and redesign really break the rare earth trap, or just loosen it?
If we rely on them alone, we probably just loosen it. China still has years of head start in refining, magnets, and export leverage. But if countries push hard on recycling, motor redesign, and new non-Chinese mines at the same time, the trap stops being a single point of failure and becomes one supplier among many.
And for us as consumers?
Keep your gadgets longer, support right to repair and recycling schemes, and pay attention to whether your next EV or e-bike uses rare earth heavy motors or newer designs.
And if you want to see how another Chinese invention, gravity batteries, might actually help solve some of these supply chain problems, watch our episode on China's gravity storage after this one.
Subscribe so you don't miss the next chapter of this series on the hidden supply chains powering the green transition.
Thanks for watching. Stay green, stay healthy, stay informed.